Your life.
All right, guys, great to be here again. It's week 4. We've had some very we've had so far an amazing time, and we've learned a whole lot, right? Um, so I'm pretty excited about today's class. I know we're going to today. I get to work with you guys on stage, right? So I'll be able to go through your code and basically code with you. So it won't just be a one-sided conversation. It's going to be a two-sided conversation. Should I say two-sided interaction, right? So I'm looking forward to seeing your notebooks and then seeing what you guys can do so far. I know you've put in a lot of work, so I'll get to commend you today, and I'm pretty excited about that. And yeah, one more thing. So we'll be coming to the teaching part of the tutorial or the teaching part of the course, right? The next 2 weeks that we have would be for your project, right? So I expect that with everything you've learned, you put that into practice for your project. For those of you who have gotten the notebook, fantastic, that's amazing. I would just need you to follow through on the project. However, I'm adding one extra project to it. It's just one project on your Collab notebook at this point, but I'm going to add one extra project. A little tasking, more tasking, but I know that with what you've done so far, you might need to do a little, personal research. But with what you've done so far, it's going to be a learning experience that I know you would surpass, right? That's one thing about um, engineering code or coding. Basically, you would need to do a lot of research on your own. You have to get comfortable with that. You have to get comfortable with errors. You have to get comfortable with finding your way. You have to get comfortable with thinking through problems from start to finish, designing the architecture, how it's going to flow from the beginning to the end, even before you start coding, while you're coding, and at the end of coding, you'd still probably need to come back and review your code or make your code better, optimize your code, right? So yeah, so I'm really excited and I'm looking forward to today's class. And without much ado, I'll just dive in by sharing my screen. All right, fantastic. Okay, so we're sharing live. I'll just go straight to our Collab notebook. I expect again that you've gone through this other videos, so having a Collab notebook shouldn't be that difficult. If you don't have the Collab notebook, please just send a mail. Send your email, and then we'll forward you the Collab notebook. We'll forward it to you, and then you could work with that. Great to see you guys. I'll call all your names. I want you guys to just drop your email so you can get the link to come on stage with me, right? Because that's the only way you can share your screen and I can see your screen too. Okay, so Jonathan, great to have you here. Or Odosa, great to have you here. Mensa, great to have you here. Sharon, fantastic, always in the class. Okay, fantastic. So let's dive into today's course or today's part of the course. All right. So today we're focusing on a quick recap. Week 1, we worked on print statements, input statements, data types, indexing, variables. Yeah, and that was pretty simple, right? That was our beginner class. I expect that everybody's accustomed to that already. Everybody has gotten a full grasp of that already. So we too worked on type conversion, math operations, comparison operators, if then statements, yeah, and then we worked on an exercise. I expect too that this is done and dusted, right? Week 3, we worked on data structures, loops, data structures and loops basically, and I also expect that that's done and dusted. That's been understood, well understood today, week 4, we are going into something a little more tasking, a little more difficult, but it's pretty easy. Basically, it's pretty easy. It's just a build up on the foundation you have. So I expect that it's not going to be that much of a task for you. So yeah, there's something called in programming. There's something called OOP. It's object oriented programming. So let me just type that out somewhere here so you get to see what I'm talking about. Object oriented programming. Right? Okay, so in some other cases you could see it as OOP. Let's quickly check out what it means. Object. Oh, fantastic. It's just right here. It's just right here. Okay, so let's see what this very URL says. Okay, object-oriented programming, OOP, is a computer programming model that organizes software design around data or objects rather than functions and logic. An object can be defined as a data field. Okay, so this is a little complex. I need something very simple. Oh, I like this. Yeah. Okay, so it says object-oriented programming, OOP, is a programming paradigm. That means a programming concept that relies on classes and objects, right? Let's go in and see what more it has to say. Let's see. Okay, relies on the concept of classes and objects. Okay, we're familiar with that. We've gone past that. It's used to structure a software program into simple, usable pieces of code blueprints. Oh, fantastic. Okay, okay, okay. So basically, what a simple way to understand this would be, so you might want to do code the same thing several times, right? But instead of just like the concept of variables, where you put in data, right, and then later you call that variable to get the data you put into it. It's just the same concept. For functions and classes, you might want to do something or do a particular task. Instead of having to rewrite that task over and over and over again, all you have to do is create a class that defines the steps that task will be carried out with. Then all you have to do is now customize that class. So, for example, I want to travel to the US from anywhere in Africa. Okay, let's use the giant of Africa. Let's use Nigeria, right? So you want to travel to America from Nigeria. You probably would need to take a 6-hour flight to the US, maybe Atlanta, and then from Atlanta to any other. You might not get a direct flight, right? So it might be 2 flights. So one flight takes you to Atlanta or any other place, international airport in the US, and then you take another flight from that airport to your destination, right? Those are 2 steps. Now, supposing you want to put that into code, it would just be something like, anytime I want to travel, I'll board the plane. You're defining concept now. I'll board a plane, right? And once I enter into the plane drives up to the first airport, and then from the first airport it goes to the second airport. Then I alight. Now that's just the process. Now you could take that and say, okay, function for traveling, maybe function is called traveling. So anytime I want to travel, maybe I want to travel to somewhere else that's not the US, I could just take that to China and take the country that should I say the country I'm starting from, right? And then take the destination, right? So while the function is running, once I get to the first airport, it's going to tell me, oh, I've gotten to the first airport, and then once from there, it will take to the next airport, and then tell me, oh, you've gotten to the second airport, or you've gotten to your destination. Now I could still take that same piece of code. All I need to do is, if I'm going to another place, I'll just pass in a different name or different cities or different countries, and then the same process, right, will still be repeated. So once I get to the first country, it prints I've gotten to the first country, and then it takes me to the second country and prints I've gotten to the second country, regardless of whatever country. The only thing I needed to do is just pass in my where I'm starting from and then my destination. That's all I need to do. I created the function only once. I hope that makes sense, right? So let's put that. So that's object-oriented programming. You're creating a concept, and then you're making objects of objects of that particular concept, that particular class. You're customizing it to your use case or to another use case, right? You're making reusable codes. Another way. Now, of course, I welcome you to do more research on your own. You would need to digest a lot more information, and then, of course, get practical with it before you get the full grasp of it. This is a part of coding that takes a little more time, just a little more time, but we should be able to work together to make it beautiful. All right, to make it beautiful at the end. So let me just see if every other person has dropped their email, and then I'm expecting you on stage because I'll need to work on this with you. Okay, Mensa.
Hi, Mr. Daniel. So
Hello.
anybody that wants to come on stage has to send their email address so we can send them this link that they can join and come on stage.
Yeah,
So if you want
absolutely.
to come on stage, identify by sending your address. I'll send you just click on that address and you'll be able to. Thank you.
Fantastic. All right, so we have some people dropping their emails already. Jonathan, Mensa. Mensa, I can't make complete sense of this. Your email is this CN Conley? Please, can you retype it so it's clear? Allow me. Fantastic. Okay, fantastic. So we have some guys. I'm hoping to see you on stage ASAP. Meanwhile, I'm jumping to our work for today. All right, so functions. So basically, I just explained the concept of functions, right? So let's make it a little bit more practical. Here you would see hi. In your Collab notebook, it might be a little different, but you just need to look at this because I made some changes to it. You just need to look at this, right? And then replicate that on your own end. Yeah. Okay, so I'm creating a function to say hi to anytime I call the function, it just says hi. So all I need to do, or all I've basically done is just I'll type it out, let's call the function say hi, right? You have to use the parentheses, right? So anytime say hi is called, it has to print this. So if I run this, let's connect. Okay, so this is stored in the memory, right? It is run. All right, so what we can do, I should do this first so that we're starting afresh on a new page. Okay, I'm going to redo that, reconnect. Okay, fantastic. So it's stored in the memory, right? So all we have to do is take this function name, right? Type it out here, and then of course, add the parentheses to show that it's a function, and then it prints hi. Supposing I add something else, print something else anytime say hi is called, say print I am happy to be here, right? I'll run that again, so the memory takes it in, and then once I run this, you can see. So every time the only thing I have to do, I don't have to, I want to run this, say, I want to do this a couple of times. Yeah. Say I want to do, let's make it a little more dynamic. Let's make it a little more dynamic. I am ecstatic. How about get the spelling for ecstatic? Oh, excuse me. Let me just confirm. Okay, missing a C. Okay, so let's use this as hey. Now, suppose I want to write this several times. If there were no functions, I would have to write this. I would have to type it out several times. But all I need to do is just put it into a function. Anytime I call the function, everything inside that function um, plays out, right, or runs. So if I do this again, say I type, say, hi, the same thing. All I needed to do was type just this short code, right? And everything inside it plays out. Okay, so I'll just remove this. That's the concept of functions, right? Let's make it a little more interesting. So here we're going to print name. In this case, okay, let me break it down. In this case, this function is taking in a parameter, right? It's taking a parameter in, and the parameter is called name. Of course, it could be anything. It could be depending on what you want to use it for. But in this case, I wanted to print out a person's name. So I'll pass in a parameter called name, right? And then once I type print and then pass in the person's name, it'll print out the person's name that is here, right? So everything inside, supposing I do print name again, so it's going to just basically imagine this to be a variable, right? So you're passing in the variable into this point or into this line of code, and you're passing the same variable into this line of code, right? So if you store that and you do, let's wipe this out for a second, right? And you do this, it's going to give you an error. Why? Because it's expecting an argument, right? Okay, so I should explain the difference between an argument and a parameter. So an argument is what you pass in. A parameter is the space that is made for what you pass in. I hope that makes sense. So in this case, there's a parameter here that needs to be filled. This is a parameter. At this point, this is a parameter. Here, I'm passing in an argument into this parameter. This is an argument into this parameter, right? I hope that makes sense. So in this case, I'm putting putting in the positional argument into the name parameter, right? So once I run that, good. So it prints out Daniel 1, prints out Daniel again. So that's basically what's happening here. Okay, so that's the concept, pretty much easy. That's the concept of functions. Okay, so let's take in greeting. Let's try another function. Okay, so this is taking in two parameters, right? Greeting is taking the name parameter and the age parameter, and then we're telling it what to do with the name argument rather and the age argument. So we're telling it that once you take in those two arguments, then print out a formatted string of hello name. I know you are 8 years old. Nice to meet you. This should make perfect sense to you if you have been following through on the class. All right, so it's just a formatted string that um, um, allows us passing variables, right? Okay, so we're going to store that in the memory, and we're going to put greeting 99 and see what happens. Good, fantastic. So it takes in Daniel and replaces as name, and then it puts Daniel here. That's why we have hello Daniel. And then it takes in age and puts it age value, which is 99, and it puts it here, age years old, right? So that's basically how functions um, are used. They are pretty much very efficient, or they make our code very efficient because they give us the ability to reuse code. So supposing I wanted to greet several people, maybe Sarah or Sharon, maybe Sharon, and Sharon is say 50 years old. I know Sharon is not 50 years old, but let's say Sharon is 50 years old. Um, do you see that? Um, let's use a for loop. Let's make a list of names, or because we need names and dictionaries, let's make a dictionary. Let's call it students, right? Students, and put that in, and then we call Sharon. Of course, I'm sure we know what this means by now. We've worked on dictionaries. So we say Sharon is 50 years old. Then we're taking James and 40, and we're taking La Wumi and give that 30, and we say Jonathan and give that say 60, and let's do one last one, Mensa, and give that 45. Right? So we've created a dictionary of students. We've mapped key value pairs. The values are the integers, the keys are the names, right? So we want to pass this. What we could do is we could iterate through the student list. So for keys, values in students, yeah, or just students dot items, but let's see. Students greeting open key and value. Let's see this. Let's see dot items. Oh, okay. Oh, let's just call it name. Why not? And call it age. So call this name and call it age. Again, you could have errors like this. Oh, fantastic. All right. So hello, Sharon. You passed in the first instance. Sharon is the first name, and 50 is the age. So hello, Sharon. I know you're 50 years old. Nice to meet you. Oh, I feel like we should add something to this. Should add an exclamation mark because we're super happy to meet you. Okay, so let me just do that, and let me run this again. Okay, fantastic. Okay, so the first instance we have Sharon and we have 15. Right, next instance we have James and 40. I hope you understand this. So let me see if anybody's on stage with me.
Yeah, hello, Mr. Daniel. We have some people back on stage, but I don't know if they
Okay.
want to share the screen here or not.
Okay. So guys, if you're on stage, please can you just signify. Can you signify,
We have
please?
we have Jane, we have Musa, and we have um, Rabba. So I don't know if they want to share this one.
Okay, that's fantastic. Okay, guys. So that means I'll need to stop sharing, right? Hello. I'll need to stop sharing.
Yeah, so I don't. Yes, no, you don't need to stop sharing. Don't worry. I just want to know if they want to share. I don't know.
Okay.
So
Okay.
let me bring Jane on board.
Okay. Fantastic. All right. So while Jing is coming on board, I just quickly finish up on functions. So, guys, you understand the concept of functions. It gives you the ability to reuse code. You only have to do the arrangement or the sequence of the code once, put it into a function, and then run that function several times by passing in arguments into the parameters you make when you're defining the function, right? So I hope this is very clear. This is pretty basic, and it's something you should understand by now. All right. So okay, so let's go into classes while I'm waiting for the other guys to come into the stage. Okay, so the concept of classes is now sometimes you might want to group functions, right? Sometimes you might want to group functions. So supposing we want to group all these functions into a particular name. Um, so let's see. If I wanted to group it, what would I do? What would I call it? If I wanted to group this into meeting, yeah. Okay, yeah, and your classes have to start with capital letter. Functions are small letters. It's just by convention. Um, yeah, so this is fine. Now I'm putting several functions into this class, right? I would, but you have to, we have to add something else to it. The idea is so you don't want to always have to call functions. You want to make it as structured as possible. You want to make it as small, your coding as little as possible, right? So that's why you have to sometimes you might need to group your functions, and that's what classes help you do. Okay, so def for classes you need to include an init and then a self. This is compulsory. This is what shows that this is a class. Meeting is a class. You must have an init function. If not, you're going to have an error. And you must have, um, again, the name of your class has to be a capital letter, right? So you would have, guys, I want to see your code. Can you guys come on stage and share your code? Can you guys come on stage? Fantastic. Fantastic.
So this is the code for Laomi. I don't know if Laomi is online. Can you hear us? You can explain us. You can explain your code, please.
Okay. So allow me. I think your mic is muted. Can you unmute your mic so that we can see?
I can hear
I'm
you.
not. Oh, fantastic! Allow me. So great to see you.
My name is actually Shemilere.
Oh, Shimilori. Okay, great. Nice to meet you, Shimilori.
Thank
Okay,
you.
so this is your code, yeah?
Yes.
Okay. What is your name? I can call you Simi or Shimi. Okay. Praying such a wonderful name. Okay. Um, age, how old are you? Fantastic. 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 Great. Shimilere, why are you not using Collab?
No reason.
Okay, so can we push it to Collab? Like, can you
Yes.
open Collab notebook. Just go to your tab, your browser tab, and open a Collab notebook. And while you're at that, have you started working on the functions?
Not yet.
Okay. Okay, so fine. You could just work on that. You can start coding it out basically. Who else wants to share their screen? Shimler, fantastic work. This is actually pretty dope. This is good. Good. Okay. So let's head back to the work, to our coding. Okay. So like I said, class meeting, def init, self. What is this going to take? Let's say it's not taking anything. Okay. Let's say it should take a name, right? Let's say it takes in first name and last name. Hey guys, I want to see somebody who is coding this out with me. So for this, we'll print self the first name. I'll explain what this means. The moment is equal to first name self dot last name is equal to last name. Okay. What else? Okay, so let's take in age here too. Age self dot age is equal to age. Okay, so why are we doing this? To explain this, you would have to practice it. You would have to practicalize it. So, or I'd have to show you how to practicalize it. So we have to, first of all, you need to instantiate your class or create an object of your class. What that means is you want to take everything you have, you want to be able to use this class. So what do? You could create something in variable called meeting and then pass that class into it, right? All you have to do is, this is our variable name, this is the class. Use the parentheses here. Remember, there's no parentheses here, but when you're calling it or when you're instantiating it, you instantiate it with the parentheses to show that it's a, and we have the capital letter here, so that it's a class, right? But this would give us an error because in functions, when we're passing in parameters, we just put the parameters, we just put in the argument beside the function, beside the name of the function. But in classes, we put in the parameters in the init function. So imagine this is just like if you were functions, this is how it would be. If you were functions, something like this, but it's not functions. So for classes, you just put in the name, and then these are the parameters that the class would take, right? So you just put in first name, Ronaldo, and last name, Cristiano. Age, I'm not sure of his age. Let's go with 30. 30, right? We did not bother about the self. I'll explain. The self has a purpose, but it doesn't really matter. It's not a parameter, right? The rest are parameters, but the self is not a parameter. It's just something to show or something that links the parameters. Okay, so passing Ronaldo as a first name, passing Cristiano, or I'm not sure whether it should be the other way around. Okay, so, and then age, right, which is 30. Once we do this, we're saying, and then we're going to take in this first name that is here, right? We're taking it, and then we're saying self.first name. We're adding self because we might want to use the first name in other functions here, down here. And so to call it, so if you put self, it shows that it's collecting. It should check for where where first name appears in the whole class. That's inside all the, to check all the functions to see where first name appears or where first name was defined, and then to take whatever it was passed into it and give you the ability to use it in other functions. That's what this self is for, right? So you're saying I might want to use first name in other functions. For me to do that, I will need to pass in the first name that was created here. I might need to pass it into this self.first name so that I can use it in other functions. The same thing for last name and same thing for age. That's what this means. So for me to now use it in other classes or in other functions, I'll need to probably add hi self first. So this shows that it should come here and look for whatever I type here. So print out, I could just do self dot first name, right? Do you see that? I can call this first name was not defined in this function. Remember how defined, you know what? I should do this in a new tab and not, just hold on guys. Okay, so I should create this in a new tab. Okay, so I'm calling self.first in this function here, but it wasn't defined in this function. It was defined in the init class or in the init function for the meeting class, right? But I'm able to do that because of the self. The self is what ties the two of them together. Self ties this function to every other function here, right? Okay, so I'm going to do self here to as well do, let's change this from say hi to print f name, first name, and then print last name. Self, we could call this self dot last name, and we could call this self2 and put in something self dot last name here, and then put in self dot first name, right? And then of course we want a space in between. This would give an error. It has to be self2. Okay, so once we do this, we store it. So let's test it out. Let's test our class out. So we have meeting, right? Remember, you have to pass in first name, Cristiano, last name, this is last name, Ronaldo, and then passing an age. What's the age? We said 30, go with 30. Remember, so this is first name, last name, age. First name, last name, age, right? So we'll store that. Okay, fantastic. Now we're going to test it out. So now we have it instantiated as this meeting. So what do? Meeting dot print name. Do you see that? Oh, sorry, print f name. Do you see that? We're saying meeting dot print f name so that this particular function will run. Let's try it out and see. Do you see that? It printed the first name. If we try it again, This time around, we want the last name. Do you see that? Try it again, but we want greeting. Right? Let's run that and see. Fantastic. Do you see that? Hello, Cristiano Ronaldo. I know you are 30 years old. Nice to meet you. Do you see that? So that's what classes do for us. Imagine I wanted to create another one. Meeting Jennifer Lopez. Let's go with 40. But let's call this meeting 2, right? So if you just save it, I'll just take this. Yeah, I'll just take this, come down here, and oh no, okay, still fine. I'll just do meeting 2 dot print f name, meeting 2 dot print last name, meeting 2 dot greeting. Yeah, so this should be fine. Do you see it? All right, that's how fantastic classes can be. All right, good. Okay, so another implementation or some other things you could learn about classes. So in this case, again, we have a class called first car. We're defining this particular class doesn't take any function, right? This is a very extremely basic class. All we have are 2 variables, model Honda and color blue, right? So again, we instantiate the first car. We instantiate the first car class, or we get an object of it. This is called the object of this first class. And then once we do that, we just do car.model to tell me what it has in the model, what is stored in the model variable. So once we do that, you can see in first car.model, we have Honda. First car.color, we have blue, right? Again, we try something else. Just pick this out. Here, but let's call this car 2. Yeah, so car 2 here, car 2 here, and we have this, right? But we could change this, we could change this. So we could do a car 2 dot model, it's equal to Toyota, right? And then let's see what happens. Do you see that it has been changed? Only for car 2. It's not changed for car 1, right? So that's it. But let's move again. Let's move further. For this one, we have an init class. We have an init function rather. And inside the init function, we have a self. Remember, I said so that means if we had other functions, we'll be able to use this self to call the price, call the color, and call the model, right? So if we do this, we instantiate it. Okay, so we have a print statement here. It's not necessary. We could just remove that or just basically wipe it off. Okay, so once we run that cell and then we check for what is in price. Oh, this should be car. Should we call it car 2? Let's call it car 3 so that the variables are not mixed. Car 3 and then car 3. All right, so I'm sure you understand this by now. All I did was instantiate the class here, right? Put it into this car 3 and then car 3 dot price or second car dot price. You could do the same thing for second car dot color. You could do the same thing for second car dot model. It will print whatever is stored into it. Then of course you could change it just like we changed it from Honda here to Toyota here by just assigning a new value to it, right? Storing a new value inside it, right? So, okay, so let's go a little step further. Third car, okay, this one is taking in 3 parameters from the onset. This looks very familiar with what we worked in the first time. So we're taking in the price, color, model. We're using the self to pass in the price so that we can use it for other things inside the function. And then once you run this, it will give us an error. It doesn't know what third cam is. So you need to store this in the memory first and then rerun it. Okay, so I hope that makes sense. Toyota for model, wine for color, 50,000 for price, right? Okay, so let's do a very simple function, operations function. We have self, again, you understand what this means. We have the operations called class, or we have the class called operations. We have an init function so that takes in the parameters. We have self to allow us to use the parameters in other functions. We're taking in A as the argument and we're taking in B as the argument, right? So we're saying whatever I stored in A should be stored in self.A. Whatever I stored in B here should be stored in self.B. Okay, so, and then we have a function called add to do addition. And so we're just going to add, just going to add whatever was stored into A and whatever was stored into B, and then we're going to add it and return the answer here. Notice I'm not using print statement here. Print statement is different from return. Most times it's better to use a return because you might want to pass your answer into something. I will explain what that means. Just give me a few moments. We'll get there in a jiffy. So we have subtract. So basically we're saying self.a minus self.b, and then we have an answer, and then we return the answer. The same thing, self.a multiplied by self.b, which is a times b. Mol answer, return mol answer. Then we have divide, self.a divided by self.b. We have divide answer, return divide answer, right? Okay, so this is fantastic. Let's test it out. So we're instantiating the class operations here with 2 parameters, A and B. A and B is 4 and 5, right? Okay, so we have ops 4 and 5. So once we do that, we have our class inside this. So we're saying that the name of the class reference the function. We're calling a function called add. We're calling this first function called add. So that means this first and this first function should run. Then we're calling the subtract, meaning the next function would run. We're calling multiply, meaning the next function would run. We're calling divide, the next function would run, right? So let's test it out. Oh, we have, okay, it's not defined. That means we've not yet stored it in the memory. So once we store it in memory, let's check it out again. Oh, fantastic. Okay, so we're saying 4 plus 5 is 9. Fantastic. 4 minus 5 is minus 1. Fantastic. 4 times 5 is 20. 4 times 5, 20. Here, divide 4 divided by 5 is 0.8. Okay. Now, let me show you the difference between print and return. Supposing I use return, I use print here. All right, so let me store that in the memory so it knows what I'm talking about. I can store all this into, say, let me call it answer. Let me call it, I could take whatever was found or whatever is the answer, whatever it returns as the answer, answer 2. Let me comment this out so that we just work with 2 for now. So once I do this, nothing is going to show because I'm basically passing the answer into this variable. I'm passing the answer into this variable, right? So if I wanted to print out the answer, I could just do print out ans1 and print out ans2. Let me see what that's going to be. So we have the addition here is 9. The answer from subtract is -1. I could use this for other things. Maybe I want to put it into a formatted string or I want to use it for something else entirely, right? So I ran the function, passed the answer that was gotten from the function into a variable that I can use somewhere else outside the function. Now, but if I used a print statement, like I used a print statement for multiply, here, and I wanted to pass that into a variable, it'll give me an error. Oh, it didn't give me an error. Okay, but let's see. And 3, nothing is stored in ans3. Let's try that. Nothing, right? So what happened was it didn't return. It's because it wasn't returned. There was nothing returned. That's why there was nothing stored in ans3. It did run, but it didn't store in ans3. The only way it can store in ans3 is if you use a return instead of a print, right? So we want to change that back to return, right? So now if we do this, it's going to store, should store. Yeah, okay, and then if we print it out, we should get our 20, right? So yeah, you could play around with this. Think of any idea you want to implement and basically just try it out. Try out classes, try out functions. You'll definitely be needing them for your project and for your assignments. You would also need them for the second project you'll be working on. Okay, so based on this, I should be wrapping up now, but I should explain the project to you guys. All right, so project 1, you're to create a guessing game. The game avatar would be called Damien, right? From the onset, Damien randomly selects a number from 1 to 100. When the user starts the game by inputting start, Damien would welcome him to the game and ask the user to select a number, or ask for the user to select a number. The user has 3 guesses, after which the game is over. If the user guesses the right number, the user wins and the game ends. So during the 3 guesses, if the user guesses the right number, the game ends. You tell the user that he has won, or Damien tells the user that it has won, and then prints out, and then game ends. If the user doesn't get it right in his 3 guesses, he loses the game to Damien. Now, what would you need for this project? Number 1, you're going to need to know how to generate random numbers in Python. So you can do research on that. Check for how to generate random numbers. So once you get that random number, you store it into a variable, right? Once you store, the next step would be for you to go into a while loop. That while loop would ask the user inside the while loop, or while true, it goes into a while loop. Inside that while loop, you would ask the user to select a number. Now, between 1 and 100, if the user guess and the user has just 3 guesses, you also want to make a variable for the number of guesses. So while outside the loop, but while inside the loop, the user guesses. If he doesn't get it right, you compare his guess to the random number that was generated. If it's equal, if that comparison gives you a true, that means you break out of the while loop. If it gives you a false, you go over the while loop again, or the while loop continues until you have a true. So there are only 2 ways the while loop ends. You have a true, that means the guess number is equal to the random number that was generated, or the number of 3 steps is over, right? Number of 3 steps, or number of 3 guesses is over, then it will just end. Yeah, I think that's enough clue for you. That's enough clue. So you're using while loop, and again, you know that at the end of your while loop, you want to add 1 to the number of guesses, so that it starts from 0 and then it climbs to 1 and then it climbs to 2. If you can check your while loop, and then it climbs to 3. Once it gets to 3, there's no answer. If it won't climb, instead of climbing to 4, it will break out of the while loop. Okay, that's plenty int. Project 2. You have to create another game as Damien as the avatar, and this game will be called Know Your Continent. So basically, you want to ask the user questions like this: what is the capital of? Now you can use your own continent, the continent you're in. If you're in North America, that's fine. You can use all the countries in North America. If you're in Africa, you can use all the countries in Africa. If you're in South America, or you're in Australia, or whatever continent, you just have to outline all the countries in that continent, and then ask for generate 4 options that show the capitals in that capitals in that continent. And then, of course, the true answer, the correct answer, would be in among the options. All right, so it's going to look something like this. What is the capital of America? Of course, the capital of America is Washington, right? And it comes in as option D. If the person selects Texas, New York, or Florida, it's a wrong answer. And then you can also ask for what is the capital of Canada. Now, for as many countries that exist in that continent, at the end of the game, you're supposed to count how many questions the person got correctly, and then say, oh, you got so and so questions correctly, or you got so and so number of countries correctly, but you didn't get so and so number of countries correctly, right? So that is your second project. What would you need for this? Okay, you need a while loop. You need to get the list of all the countries, the list of all the capitals. You need to know how to shuffle your capitals, generate random, um, select 3 capitals from the entire number of capitals, and then one of the correct answer, or one of the correct capitals. If that makes sense, then you are supposed to put that into an option. You're supposed to print this out, and of course, you should have an input statement where the person imputes the option he wants, and then you should have a counter, something that counts. You should have two counters. So maybe correct and incorrect. Correct, once the person gets it correctly, correct would increase by 1. Once the person gets it incorrectly, incorrect would increase by 1, right? So, and then at the end of the day, you show the correct versus the incorrect variables. Okay, so on that note, I believe that's a lot of hints to help you guys. On that note, I'll see you guys in next week. Um, Jane is asking, how do you download Google Collab? Jane, you don't download Google Collab. Basically, you just go on your drive and type in. Sorry, you just go on a new tab on your browser and type in Google Collab. Once you do that, you would see Google Collab appear for you. You just go on your browser and type in Google Collab. All right. So on that note, I will see you guys next week's class. If you have issues downloading, please just go to the previous classes and you would see the guide there. All right. So guys, have a wonderful day, and I'm looking forward to you guys acing the project.